Welcome! In this video, we'll explore how machine learning can predict house prices with incredible accuracy using real-world data and powerful regression models. House price prediction is one of the most practical applications of data science. Real estate pricing depends on many factors like location, area, condition of the house, number of rooms, and even amenities like garages. Using machine learning, we can analyze thousands of property records and make accurate price predictions useful for buyers, sellers, and investors. In this project, we worked with a dataset containing over 2,000 housing records. We performed data cleaning, preprocessing, exploratory data analysis, feature engineering, and finally trained multiple machine learning models to predict house prices. The goal was to find which model performs best and why. To prepare the data, we handled missing values, removed inconsistencies, encoded categorical columns such as location, condition, and garage, and normalized the numerical features. This step ensures our models learn efficiently and produce reliable results. Then we conducted exploratory data analysis, also known as EDA. We explored how features like area, location, and condition influence price. For example, houses in downtown areas and those in excellent condition tend to cost more. We also checked for outliers and examined correlations using heat maps. To improve prediction accuracy, we engineered new features. One of the most important derived features was the location ratio, a metric that captures the average pricing patterns of different regions. Feature engineering helps models understand hidden patterns in data that raw columns may not reveal. We trained and compared 3 machine learning models: linear regression, simple, fast, and interpretable; decision tree regressor, captures nonlinear relationships; random forest regressor, an ensemble model that combines many trees for higher accuracy. Among these, the random forest model performed the best, achieving nearly 99.9% prediction accuracy. Model performance was evaluated using R-squared score, mean absolute error, and mean squared error. Random forest achieved the highest scores across all metrics, making it the most reliable model for real-world deployment. The results clearly show how advanced ML models can outperform traditional regression methods. This project is a complete end-to-end machine learning workflow, perfect for students, beginners, and anyone preparing for data science careers. House price prediction models can be extended to car pricing, rent prediction, property investment analysis, and other real-world applications. Thank you for watching. If you enjoyed this explanation, make sure to like and subscribe for more machine learning project videos.